Okay, so question 2 was looking at a momentum problem. And so we first of all just had to work out what the speed of the combined masses were moving off. So we had to use our idea that momentum before is equal to the momentum after. Okay, so in this case before I've got the momentum of the bob plus the momentum of the object, and then afterwards the momentum of the bob and object combined. Okay, now because the object is stationary, I'm going to leave that as 0 so I can cancel that. So before my momentum is 0.075 times 0.8, and then afterwards, okay, this time I've got double my mass because I've got the two of them together, so I've got two lots of 0.075 multiplied by the velocity. I'm going to rearrange for velocity, so 0.075 times 0.8 divided by two lots of 0.075. Again, these cancel out to give me 0.4. It's actually a nice little trick knowing this, because when we have objects that have the same mass, and if one's stationary and they move off combined, okay, the velocity that they have when they move off is going to be 0.4. So not 0.4, it's going to be half of what it initially was. But it did say calculate, so I had to show the calculation for the first mark. The next bit was then saying that show the collision is inelastic. Now, show always means you need to give a calculation. Okay, you can't just say it, you have to give a calculation there. All right, so in this case, we're going to say inelastic. It means that kinetic energy is not being conserved, so the kinetic energy before is not equal to the kinetic energy after. Okay, and simply then I need to work out my kinetic energy before, so a half mv squared. So 0.075 times 0.8 squared, okay, giving me 0.024 joules. Okay, afterwards, this time around I've got double the mass, so I do two lots of 0.075 and the spin velocity was 0.4, so I have to do a half multiplied by that to give me half mv squared to give me 0.012 joules. Essentially then I just say they're not equal, it is elastic, and just remember to show that last stage. A lot of people leave it here, but it's asking to show it's an elastic, so you need to have that little statement written down. The last part then was saying describe the changes in the gravitational potential energy of the oscillating system starting from t is equal to 0 as it oscillates through one cycle of motion. A few people got a little bit mixed up with this when reading the question. So T0, the bob is moving horizontally to the right, so T0 is actually up here moving. I think some people assumed this was T0. Okay, so I'm rather than like linking to T0, I'm basically just going to describe it. So I say gravitational potential energy is the greatest at its highest extreme height or at the maximum swing, okay? And GPE is minimum when it's at the center of the bob, so making it really clear what I'm trying to describe in this one. Okay, so having both of those for that final mark out of 5.